So today we're going to be looking at how the relationship between decimals and fractions work, and how to go from a decimal to a fraction, how to go from a fraction to a decimal, and then how to kind of compare and order fractions and decimals as well. So we'll start with going from a decimal to a fraction. So the way we go from a decimal to a fraction is, as it says here, we take a look at the decimal and we look at how many digits behind the decimal does it have, and that will tell us what kind of number to put on bottom. Now when we start making our fraction, the number on bottom is always going to be power of 10, which means 10, 100, 1,000, basically a 1 with some number of zeros behind it. That's what we want on bottom when we first start to convert our decimal. And we tell ourselves how many zeros to put behind there depending on how many digits behind the decimal there are. So let's take a look at this one. 0.37. How many digits are behind the decimal? Well, there's 2 digits behind the decimal. So what is our fraction? Well, our fraction is the number that's behind the decimal, so 37, over, and then because there's 2 numbers behind the decimal, the 3 and the 7, we put 1 and then 2 zeros. And so our fraction is 37 over 100. And if we could reduce it from there, but we can't, so we'll just leave it as 37 over 100. And that's all there is to it, really. Another way you could do this, if you want to kind of have a shortcut and you're good with the verbiage, is you could look at 0.37 and say that is 37 hundredths. Because remember, this spot right here where the 7 is, that is the hundredths spot. So if you remember that place value, you can say, well, if it's 37 hundredths, it's going to be 37 over 100. If it was, 4 thousandths, it'd be 4 over 1,000. So if you know the language used for the place value, you can get the right fraction that way too. So just a few quick more examples, just make sure we have this. 0.85 or 85 hundredths would be 85 over 100. Okay. Now, because both of those can be divided by 5, I'm going to go ahead and divide both those by 5 to simplify it. So I'm going to divide this by 5 and divide this by 5. Remember, simplifying is just the act of reducing the numbers in a fraction to smaller numbers, essentially. And you can only do that by dividing the top and the bottom by the exact same number. So 85 divided by 5, well, that's going to be 17. And 100 divided by 5, that's going to be 20. 17 and 20 can't be divided by anything that's the same. So this would be our end fraction. Okay? So this number, and this number are all the same. Okay? It's all the exact same value, just written 3 different ways. So it's important to know here that we're not getting a new number, we're simply changing the form of the current number. 0.25 is the same way. 25, so it's 25 over 100. If we divide the top and bottom by 25, we can actually get 1/4. Okay. 25 and 75 and 0.5, those are all quarter values. So you think of 0.25 as 25 cents, which is 1/4 of a dollar, because it takes 4 quarters to make a dollar. So sometimes you have little tricks like that for some of the more commonly used decimals that you can apply. Now the last two all had a 0 in front of it. This next one is 2.34. So how do we do that one? Well, the way we do that one is we actually change it to a mixed number instead of just a fraction. So we change 0.34. Look at the 3/4 first. 3/4, if I make that into a fraction, is 34 over 100. I'll cut these both in half by dividing them by 2. Simplify it down a little bit. That will give me 17 over 50, which can't be reduced anymore. So my fraction part is 17 over 50. But what do I do with that 2? Well, any number that's in front of the decimal simply gets written in front of the fraction. Okay? So this is a mixed number, would be 2 and 17/50ths. Or if you want to do it as a fraction, you can do the little folding method. So if you want to write this mixed number as a fraction, what you do is you take the bottom times the big number. That gets you 100. And you take the big number plus the top number, and that gets you your new numerator. So that's going to be 117 over 50. Okay? That's how you go from a mixed number to a fraction. A tad bit out of scope of the content here, but it's a good thing to know regardless. Okay? So if you have a number in front of your decimal other than a 0, change it to a mixed number first, and then if you really want to, change that mixed number into a fraction after you have it. And just one more quick example here that I didn't put down, but we can do, is let's say we had something like 0.027. Okay. The way we would write this as a fraction is we'd say, okay, 27 is the number, so 27 over. How many spots behind the decimal are there? Well, we have the 0, the 2, and the 7. So it's 1, 2, 3 decimal spots. So I'm going to have 1, 2, 3 zeros. And that would be my fraction for that. So again, it all boils down to figure out what number is behind the decimal, then put that number on top, then figure out what power of 10 is going to go on bottom, and put that on bottom, and then reduce if you need to. Now, going the other way is even less tricky, because all it is just division. Remember, every fraction is basically an unsolved division problem. So 3 over 8 is the exact same thing as saying 3 divided by 8. So this right here is actually a division problem, 3 divided by 8. The only problem is that it doesn't divide nicely, so we usually leave it as a fraction. But sometimes we want it as a decimal. So how do we go from this fraction / division problem to a decimal? Well, we simply do the division. So we write this as 3 divided by 8. So remember, the top number goes inside the long division, the bottom number goes outside the long division, because it's 3 being divided by 8, not 8 divided by 3. It's 3 divided by 8. Now, 8 can't go into 3, unfortunately, so we put a 0 right there. And now we're out of numbers, which is usually why we leave as a fraction, because we come across this problem. But if we really want to continue further, all we have to do is put our decimal, bring it up, put our decimal there, and then tack on a 0. Because remember, 3, right here, 3 is the same as 3.0, is the same as 3.00, is the same as 3.000. So it doesn't matter how many zeros I put behind the number, it's not going to change as long as the zeros are behind the decimal. So that's why I can keep putting zeros there and not change the number, but I can still continue the problem, because now I can do 8 into 30. Now I have some stuff I can progress on. So 8 into 30 goes into it 3 times. 3 times 8 is 24. Subtract this, I get a 6. I don't want a remainder, though. I want a decimal. So, like I said, I can tack on another 0 and bring it down. Okay. Again, no matter how many zeros I write in, I always have the same number. 8 goes into 67 times. 8 times 7 is 56. Okay. I subtract that, get a 4. Still not done yet, so I'm going to tack on another 0 and bring it down. I'm just going to keep doing this until I get no remainder, or until I figure out that it's going to go on forever, or if there's a pattern to it. But luckily for me, 8 goes into 40 exactly 5 times, which ends the division, and in fact gets my decimal. So the decimal form of 3 over 8 is 0.375, or 375 thousandths. And that is how you change a fraction to a decimal. It's just division from the top divided by the bottom. And again, you should have no remainder. You can keep going and going and going until you get to the end. Let's try a few more just to make sure we have the method down. 4 divided by 5. Well, okay. 4 on the inside, 5 on the outside. 5 doesn't go into 4, so I put a 0. Decimal, decimal, put another 0. This one ends pretty quickly because 5 goes into 48 times with, again, no remainder. So my decimal is just a very quick 0.8. Short, sweet, and easy. 7/5 is much the same way. 7 on the inside, 5 on the outside. Now in this case, 5 actually does go into 7. It goes into 7 one time. 1 times 5 is 5. Good 2. But now I'm stuck again. So I go what I did before. Decimal, decimal, bring a 0, carry it down. And again, 5 goes into 20 pretty nice and evenly. 4 times. And so my decimal is 1.4. Okay. So it's not always going to be a 0 right away. If it's a proper fraction, which means the top is smaller than the bottom, then it will be a 0. If it's an improper fraction like this one just was, 7/5, where the top is bigger than the bottom, if it's an improper fraction, then you will have a number in front of the decimal. Just a minor thing you can keep in mind. Let's try the last one here, 11 divided by 4. Again, 4 actually does go into 11 and manages to go into it a total of 2 times. Whoops, I wrote an extra subtraction there. 11 minus 8 is 3. Ran out of numbers, so decimal, decimal, 0, and drop. 4 goes into 30 a total of 7 times. 0 and drop. And 4 goes into 20 now 5 times. And so we have our decimal number there. So again, it's just repeated division, or really just one division, and you work until you get to your answer. So that's how you go from a fraction to a decimal, and before, how you go from a decimal to a fraction. And so the last thing we're going to do for this video is to make sure we know how to order and compare our decimals and fractions. So let's see fractions first. Again, they usually tend to be the more trickier of the bunch. But in this case, it's not too bad. When you want to order fractions like least to greatest or figure out if one fraction is bigger than another, sometimes it's pretty easy. Like for example, if I say what's bigger, 1/2 or 2/100ths, well, you think to yourself, would you rather have one piece out of 2 total pieces? So you have one big pie here, you cut into 2 equal pieces and you get 1. Okay, so that's 1/2, that shaded part there. Or would you rather have a pie that's cut into 100 pieces and you get 2 of them? Which sounds bigger, the 1 piece out of 2 or the 2 pieces out of 100? Well, again, the 1 piece out of 2 is going to be bigger because you'd rather have half the whole pie or half the whole pizza rather than cutting it up 100 times and just taking 2 little slices. So if they're really spread out like that, then it's easy to identify. But if you have a bunch of them and they're kind of close-ish together, it might be hard to see at first which is bigger and which is smaller. So to do that, if we have a fraction set up like this, where we have 4 different fractions, we want to compare them from least to greatest, what we do is we simply make them have all the same denominator. So we kind of unsimplify them. Okay? We make the fractions grow at times until they all have the same bottom number, and then we can just compare the top numbers. Because if they all have the same bottom number, it's like I cut every piece of pie into the same number of equal pieces, and then I just need to figure out how many pieces am I getting. So right now this says, what's better? 3 pieces out of 4, 2 pieces out of 5, 1 piece out of 2, or 3 pieces out of 10. So I have a whole bunch of different pizzas here, all cut up into different ways. The first one's cut up into 4 pieces, the second one is cut up into 5 pieces, the third one's cut up into 2 pieces, and the last one's cut up into 10 pieces. And I'm getting a different amount of pieces from every pie. So it's kind of hard to see which one's actually bigger, at least right off the bat. So what I'm going to do is I'm going to cut up each pie into the same number of pieces by making each bottom number the exact same. So you think to yourself, out of all these numbers here, I just erased my commas, but we'll have to deal with that. Out of all those numbers there, what is a good LCM? What is a good common multiple between all 4 of those numbers there? 4, 5, 2, and 10. What is a number I can multiply all those into? Well, 10 would work for 5 and 2, and of course 10. So 10 would work for 5, 5 times 2. 10 would work for 2, 2 times 5. 10 is obviously 10 times 1. But it wouldn't work for 4. 4 can't make 10, at least not by multiplying. So that's out. Okay. Whoops. Sorry about that. Can't use 10. 10's out. Let's see here. We could try 8. 4 times 2, 2 times 4, but 5 and 10 can't be 8, so I can't use 8 because it has to work for every single one. So I work my way down the list here, and eventually I get to 20. Because 4 times 5 is 20, 5 times 4 is 20, 2 times 10 is 20, and 10 times 2 is 20. So 20 works. I can make them all into 20. So I go ahead and do that. I times this one by 5, top and bottom. Remember, you want to keep the fraction balanced. Times this by 4, times this by 10, and times this by 2. So now I'm going to write my new fractions, which are not simplified, but hopefully a little bit easier for me to compare. So 3 times 5 is 15 over 20. 2 times 4 is 8 over 20. 10 over 20. Oops. And 6 over 20. Okay. Now, I can pretty easily see which one is the biggest, which one's smallest, and which two are in the middle. Because all my pies here, that's a 20 by the way, all my pies here are cut up into 20 pieces. So, which is bigger? 15 out of 20, 8 out of 20, 10 out of 20, or 6 out of 20? Well, this one's obviously the biggest one because I'm getting the most pieces for my pie there. So 15 out of 20 would be the biggest, and that means 6 out of 20 would be the smallest. So if I want to order them from least to greatest, I would go 6 out of 20. The next least would be 8 out of 20. Then 10 out of 20. And then 15 out of 20. Okay. And if you want to reduce these back to what they were originally, you can. So this would be 3/10. This would be 2/5. This would be 1/2. And this would be 3/4. That would be the order from least to greatest. Okay. So when you're ordering fractions, the first thing you want to do is simply make the fractions all have the same denominator. Once that's done, then you just compare the top numbers. Okay. So the denominator is the key for that whole part there. Now, decimals have their own method. Okay. Let's check out what they do. So decimals, you can actually, once you get used to them, you just kind of see which is bigger just because you're used to how the numbers look, work, and feel. But until then, there's a little trick you can do. Okay. So if you want to order decimals, the first thing is to compare the numbers in front of the decimal point. Because again, if you want to order these from, I didn't say here, but let's say we want to order these from least to biggest. I should say least to greatest, but we'll say biggest. Okay. As most of you know, my spelling is not the best, so forgive me on that. And so we want to order these from least to greatest. So if we want to figure that out, we want to figure out which number is the smallest first. Well, we have a bunch of candidates for the smallest, right? This one, or this one. But 1.7 and 2.08 are clearly not going to be the smallest because they actually have a number in front of the decimal. In fact, if we think about this, which is bigger, 1 point something or 2 point something? Well, 2 point something is going to be the biggest. I really don't care what's behind the decimal point. Okay? Because if it's 2 point something, anything less than 2 point something is going to be automatically smaller than it. So 2 point something is the biggest, and 1 point something is the second biggest. Because it's obviously bigger than the 0 point somethings. So that when you're comparing decimals, the first thing to do is look at the front of the decimal and see, is there any number that's clearly bigger than the others based on that alone. So we already figured out two of our places. Now, what do you do if you have numbers with the same value in front of the decimal, like a whole bunch of 0 points? How do we know which of these 0 points is bigger? Well, there's a trick. I'm going to line these all up. 0.25, 0.003, and 0.9. And what I'm going to do is I'm going to add zeros to the end of the number until each number has the same digits behind the decimal, same number of digits behind the decimal. So for example, this one right here, that has 3 numbers behind it. This one only has 2 numbers behind it. So I'm going to put a 0, that way it matches up with that one. Same thing for the bottom one. Put 2 zeros, so it matches up with that. Now everything has the exact same number of digits behind the decimal point, and what I can do is simply cover up the zeros, imagine that these aren't even there, and compare my new values. So of this, this, and this, which is bigger, 250, 003, or 900? Well, 900 of this bunch, 900 is the biggest, 250 is the second biggest, and 003 would be the least. So the whole point of decimals is to simply arrange them so that you have the same number of digits behind the decimal for each decimal number, and then simply compare the back end of the decimal. So ignore the front end, just compare the back end and see if these were whole numbers, which back end number is the biggest. In this case, 900 was the biggest back end number, so it's going to be the biggest decimal number of the 0 point somethings. So when I go to order this, my first number is going to be the 0.003. That's the smallest. Of the 0 points, 0.25 was the next up. Then 0.9. And then I have my two bigger decimals, the 1.7 and the 2.08. So again, the whole idea is to make sure the back end of the decimals all have the same number of digits. If they don't have the same number of digits, then slap on some zeros at the end until they become the same number of digits, and then go ahead and compare them from there. So, hope that helped you out about how to figure out to change fractions to decimals and decimals to fractions and how to order and compare them. I hope you enjoyed the video. Have a good day.